If A intersection B is a null set, then N of A union B is equal to N of A plus N of B. C and T. C represents the number of people who take coffee, and T will represent the number of people who will take tea. N of A is 15, N of B is equal to 10, and N of A intersection B is a null set because it's a disjoint set. In general, if A and B are any two finite sets, then we have N of A union B is equal to N of A plus N of B minus N of A intersection B. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. In my previous class, we have discussed regarding the application problems on sets. Today also I am going to take few more problems based on application of sets. So in the last class, we have discussed regarding the definition of A union B and the formula which we are going to use to solve the problems. Now let A and B be the finite set. And if A intersection B is a null set, then N of A union B is equal to N of A plus N of B whenever A intersection B is a null set. Now, suppose the elements in A union B are either A or in B, but not in both, as A intersection B is a null set. Now, suppose in general, if A and B are any two finite sets, then we have N of A union B is equal to N of A plus N of B minus N of A intersection B. If A intersection B is a null set, then this becomes N of A plus N of B because this is 0. So, then N of A union B is equal to N of A plus N of B if A intersection B is a null set, or N of A union B is equal to N of A plus N of B minus N of A intersection B if it is required to find N of A union B. Suppose if you want to find N of A intersection B, transfer this. So, if you transfer a minus N of A intersection B to the left hand side, N of A intersection B is equal to N of A plus N of B minus N of A union B. Now, suppose if A, B, C are any three sets, then N of A union B union C is equal to N of A plus N of B plus N of C minus N of A intersection B minus N of B intersection C minus N of A intersection C plus N of A intersection B intersection and C. So, these are the formulas which we are going to use to solve the practical or application type of problems in the set. Now, this is what we have discussed in the previous class. Today also I will take few more problems based on these formulas. Now, come to the first problem. These are all very important type of problems. Suppose if X and Y are two sets such that X has 40 elements and X union Y has 60 elements and X intersection has 10 elements, how many elements does Y have? This is the important problem. Now, what is the problem given? X and Y are two sets. Here, X and Y are two sets such that number of elements in X is given, number of elements in X union Y is also given, number of elements in X intersection Y is also given. What is required to find is Y. So, X is given, union is given, intersection is given. What is required to find is the number of elements in Y. Okay. See here, given that number of elements in X, N of X is equal to 40. Number of elements in X union Y is equal to 60. And the number of elements in X intersection Y is equal to 10. And what is required to find is the number of elements in Y. N of Y is to be determined. Now what is the formula we are going to use? So, this is the formula. N of A union B is equal to N of A plus N of B minus N of A intersection B. So, here N of X union Y is equal to N of X plus N of Y minus N of X intersection Y. This is the formula we are going to use. Just substitute the values, that's all. What is X union Y? X union Y is 60. N of X is 40 plus N of Y, this is to be determined, minus N of X intersection Y is equal to 10. So, 60 is equal to 40 minus 10 is 30 plus N of Y, or 60 minus 30 is equal to N of Y. 60 minus 30 is nothing but 30 is equal to N of Y. So, therefore, the number of elements in Y is equal to 30. So, N of Y is equal to 30. The number of elements in Y, N of Y is equal to 30. So, this contains 30 number of elements. That's it. Here I'll explain once again. So what is given here? Number of elements in X is 40. Number of elements in X union Y is 60. And the number of elements in intersection X intersection Y is 10. Union is 60. Intersection is 10. And number of elements in X is 40. What is required to find is n of y. So we know the formula. N of X intersection Y is equal to n of X plus n of Y minus n of X intersection Y. Substitute X union Y is 60 is equal to n of X is 40 plus n of Y as it is minus X intersection Y is 10. So 40 minus 10 is 30. 60 minus 30 is equal to n of Y. Therefore, the number of elements in Y is equal to 30. That's it. Hope you followed. Now, let us come to a similar type problem. What is given? In a group of 70 people, 37 like coffee, 52 likes tea, and each person like at least one of the two drinks. How many people likes both coffee and tea? This is also an important problem for 3 marks. Suppose if in a group of 70 people, suppose 37 like coffee. So let us represent, let C denotes the number of people who take coffee, who takes coffee, and T, capital T denotes the number of people who takes tea. Okay, C and T, C represents the number of people who take coffee and T will represent the number of people who will take tea. Now in a group of 70 people, 37 likes coffee, 52 likes tea, and each person likes at least one of the two drinks. How many people like both coffee as well as tea? Let us represent C as C denotes the number of people who takes coffee and T denotes the number of people who take tea. So how many people are there? 70. So therefore what is given? N of C, coffee union tea is equal to 70. So there are 70 people. So N of C union T is equal to 70 and 37 likes coffee. That means number of persons who will take coffee is 37 and 52 likes tea. N of T is equal to 52 and each person likes at least one of the two drinks. How many people like both coffee and tea? Both coffee and tea means N of C intersection T, which is to be determined. That's it. So C union T is given 70, N of C is equal to 37, N of T is equal to 52 and N of C intersection T, that is required to be determined. So we know the formula, since N of C union T is equal to N of C plus N of T minus N of C intersection T. Now substitute, what is C union T? 70, N of C 37 plus 52 minus N of C intersection T. So this is 70 is equal to, add this 37 plus 50, 89 minus N of C intersection T. Therefore, N of, transfer this, C intersection T is equal to 89 minus 70, that's equal to 19. So therefore N of C intersection T is equal to 19. That is, number of people like both coffee and tea is N of C intersection T is equal to 19. 19 people will like both coffee as well as tea. Okay. Now N of C intersection T is to be determined. That's all. So C union T, coffee and tea is 70. 70 is equal to N of C is 37, N of T is 52 minus N of C intersection T is to be determined. 70 is equal to 37 plus 52, 89 minus N of C intersection T. Transfer this, N of C intersection T is equal to 89 minus 70, that's equal to 19. Otherwise, you can write N of C intersection T is equal to N of C plus N of T minus N of C union T. You can interchange the formula also as you wish. Okay, right. Hope you followed this. Now, let us come to the next problem. What is the problem? In a group, there are 65 people, 40 like cricket, 10 like both cricket and tennis. How many like tennis only and not cricket? How many like tennis? So here two conditions are given. So how many like tennis only and not cricket, first part, and the second part is how many like tennis only. Now here in a group of 65 people, 40 likes cricket and 10 likes both cricket and tennis. Now let us represent, let T and C. C represents the people who play cricket and T represents the people who like tennis. So what is given? Here given N of cricket union tennis, C union T is equal to 65. Then 40 likes cricket, N of C is equal to 40 and 10 likes both, N of C intersection T is equal to 10. And what is required to find is, first find out N of T. N of T means how many likes tennis only. Now we know the formula for this. Since N of C union T is equal to N of C plus N of T minus N of C intersection T, where C represents the people who likes cricket and T will represent the people who likes tennis. Now what is given? N of C union T is 65, N of C is 40, N of C intersection T is 10. What is required to find first is N of T. We know that N of C union T is equal to N of C plus N of T minus N of C intersection T. Now substitute N of C union T is 65 is equal to N of C 40 plus N of T, we don't know, that is to be determined, minus common both cricket and tennis is 10. 65 is equal to 40 minus 10 is 30 plus N of T, or 65 minus 30 is equal to N of T. Therefore N of T, number of people who like only tennis, is 65 minus 30, that's equal to 35. So N of T is equal to 35. Okay, so how many likes tennis only means N of T is equal to 35. Now find how many likes tennis only. Now next is N of T minus C. How many likes tennis only, not cricket? That is N of T minus C is equal to N of T minus N of this cricket intersection tennis. N of T minus N of C intersection T. So this N of T is 35 minus N of T is 35. How many likes tennis means 35 likes tennis, and both 10 likes both cricket and tennis. You can subtract 10 from this. So 35 minus 10 is equal to 25. So 25, that means 25 likes tennis only, not cricket. So the number of people who likes tennis only, not cricket is 25. Okay, that's all. So here what is given? First find out N of T. N of T is equal to 65 minus 30, that is 35. And number of people who likes only tennis but not cricket is N of T minus C is equal to N of T minus N of C intersection T, cricket intersection tennis. So if you subtract N of T, that is 35 minus both who plays cricket and tennis, you will get 35 minus 10 is equal to 25. This is the required answer. Just subtract, you will get the answer. That's it. Okay. Now let's come to the next problem. So in a committee, 50 people speak. How many speak French? So 50 speak French, 20 speak Spanish, and 10 speak both Spanish and French. How many people at least one of these two languages speak? So how many speak at least one of these two languages? Now let us say similar problem. Let us represent. So number of people, the people who speaks French as F, and Spanish as S, or you can represent it as A and B. Number of people who speak French is A and the number of people who speaks Spanish as B, otherwise F and S. What is given? In a committee, 50 people speak French. N of F is equal to 50. 20 speaks Spanish, N of S is equal to 20. And 10 speak both intersection, F intersection S is equal to 10. How many speak at least one of these two languages? That is to be determined. So, what is required to find is N of F union S. This is to be determined. Okay. Now, what is the formula? We know that N of F union S is equal to N of F plus N of S minus N of F intersection S. So, this is equal to N of F is 50. Number of people who speak Spanish is 20. French is 50. Number of people who speak French is 50 and Spanish is 20. Both minus intersection is 10. So, this is 50 plus 10 is equal to 60. So, therefore, N of F union S is equal to 60. That means 60 people speak at least one of these two languages. How many speak at least one of these two languages means 60 people can speak one of these two languages. Hope you followed this. Now let us come to a next problem. So a market research group conducted a survey of 1000 consumers and reported that 720 consumers likes product A and 450 consumers likes the product B. What is the least number must be liked both the products? So, in a survey regarding the two products A and B, a market research group conducted a survey of 1000 consumers and in that 720 report that they consume a product A and 450 consumers like the product B. What is the least number that must have liked both the products? Okay. So, yes, right away they have given two products A and B. Now, given in a survey of 1000 consumers, A union B is equal to 1000. Given A union B is equal to 1000 and reported that 720 consumers like the product A. Number of consumers likes the product A is 720 and 450 consumers like the product B. Number of consumers who likes the product B is 450. Now, what is required to find what is the least number that must have liked both the products means N of A intersection B. This is the simple problem. So, these are the given condition. What is required to find is N of A intersection B. Now, we know the formula N of A union B is equal to N of A plus N of B minus N of A intersection B. Now, A union B, what is A in B? 1000 is equal to 720 plus 450 minus N of A intersection B. So, this is 1000, 720 plus 450, that is nothing but 1170 minus N of A intersection B. Transfer this. N of A intersection B is equal to 1170 minus 1000, that's equal to 170. N of A intersection B is equal to 170. So, the least number of people who will likes this both the product is 170. That's it. Now, let us come to the next problem. Now, what is the problem given here? Out of 500 car owner investigated, out of 500 cars owners investigated, 400 own car A and 200 own car B and 50 own both A and B cars. Is this data correct? We have to check whether the given data is correct. Let U represent the owner's investigation. Therefore, N of U is equal to 500. Let us represent N of U is equal to 500. 400 owned cars. So, number of A, N of A is equal to 400 given. And 200 owned car B. So, N of B is equal to 200. Okay. And 50 owned both A and B. N of A intersection B is equal to 50. Now, let us verify whether the given data is correct or not. We know that n of A union B is equal to n of A plus n of B minus n of A intersection B. So, here this is 500 is equal to 400 plus 200 minus 50. So, 500 is equal to 400 plus 150. That is nothing but 550. They are not equal. 500 is not equal to 550. That means the given data is incorrect. It is therefore the given data is incorrect. This data is incorrect. Okay. Now let us come to the next problem, and this is very important problem for 2 marks. This is a 2-mark question. If A and B are two disjoint sets and n of A is equal to 50, n of B is equal to 10, find n of A union B and n of A intersection B. Now what is given? Given that number of elements in A is 15 and the number of elements in B is equal to 10. A and B are two disjoint set, means given n of A intersection B is equal to a null set. So therefore, first answer, n of A intersection B is a null set because it is a disjoint set. And the second part is n of A union B is equal to, for a disjoint set, n of A union B is equal to n of A plus n of B. What is n of A? 15. N of B is 10. This is equal to 25. So therefore, n of A union B is equal to 25. That's it. This is very simple 2 marks. So, what is given here? A and B are two disjoint sets and n of A is 15 and n of B is equal to 10. Find n of A union B and n of A intersection B. Given n of A is 15, n of B is equal to 10 and n of A intersection B is a null set because it's a disjoint set. So, therefore, n of A union B is equal to n of A plus n of B, that is 15 plus 10 is equal to 25. Therefore, n of A union B is 25, whereas n of A intersection B is equal to a null set. That's it. Okay, very simple. Hope you followed this. So, these are few problems based on the union intersection of the sets, and these are few examples for practical type of problems, that is application type of problems. That's all for today's session. Let us meet with different concepts in the next class. Thank you very much.